Hello, everybody. Today we're going to. Last time we talked about the cell phone on which you had different kinds of CPUs, GPUs, and other things. Okay, so multiprocessing system for BSD kernels and other things. Okay, today we are going to look into in depth into some of the things how we can use those features as to configure different things and what are the things it can do, how you can change all those BSD systems into something else, how we can use even your cell phone to do some of the things features of iOS and other things. Okay, iOS is a proprietary of Cisco systems. Okay, Cisco iOS Internet Ring Operating System is a proprietary operating system that runs on Cisco system routers and switches. The core function of Cisco iOS to enable data communication between network nodes. Okay, so this is the basic thing. So you have two different systems. Then you want to connect those two systems. You make a physical connection or probably any kind of wireless connection or something like that between any two ports, and you configure that particular communication link into different forms is whether you want to have telephone things going on, or you want to have any kind of data communication, or you want to do some kind of tunneling through and things like that. So there are plenty of features that is available between to connect to nodes, and then configuring those nodes to different forms. Okay, so this is basically the operating system, how it connects. Last time we saw about BSD and Unix kernels. What are the basic things of Unix and BSD kernels? Slash is used for what? For boot process that runs on the mostly the operating system of BSD and Unix kernels reside on. Most of the commands and the whole operating system resides on slash. Okay, then after that, so the support files, configuration files of the particular system, for the hardware addresses, everything is all mapped onto the main slash. Okay, then after that, you have swap, where you can use all the processing features of the thing, in the sense that the processor is going to take all the features of those things and then use them as a kind of process management, and that is mostly to do with something with it to do with RAM. Okay, the random access memory, that is a critical thing that is used in there. RAM, or probably it might be some other, mostly it is RAM. Okay, so part of it might be ROM, but mostly ROM stays in slash. Okay, part of the thing of slash has ROM, and so it skips a few bytes and starts the operating system from ROM to actual operating system runs on slash with a part to do with ROM, and part to do with sometimes even the operating system resides on ROM, so that you can just run the operating system. So slash is basically kind of, might be there is some part of it which is only read only kind of thing. Okay, so because the basic operating system runs from there, BSD software or Unix operating system, so you cannot write onto it, kind of thing. So unless you have some kind of system calls where you can have databases and other things, where it calls those particular calls and other things. So they don't allow to write onto that particular area location or disk usage or ROM location or something like that. And so they are put in there. Okay, or the device configurations also is there. So if you want to do any device access, you have to go through the thing, and you have to get into the read only mode, and then have might be part of it is kind of allows for some kind of write access into some of the devices. What are the devices? The basic devices that we saw is like it's the CPU and GPU, and then what are the devices? You have shared RAM, and you have main memory and auxiliary memory. Then you have disk. Okay, so disk is mostly when you have any kind of disk or disk storage is for just for file systems and other things. Okay, where user file systems and other things are stored. Okay, so the basic architecture slash, then slash what slash swap, then you have slash variable, then you have slash user. Okay, so these are the basic directories of any kind of Unix operating system and other things. So these four things have different properties. As I already told you, the first one might be a ROM, and part of it might be a RAM. Okay, so it might have virtually mapped onto some kind of RAM or, mostly device things and other things. If you want to write into a device register and, kind of IO register or serial port register and, those kind of things, device mapping might be done onto the ROM also. Okay, but otherwise, most of the things, any kind of process that comes in, just put it in swap on any kind of command you give and other things. If you're going to start a particular kind of commands and configuration also, so configuration command of the system, or if you want to do change some of the things, or if you want to run any kind of process, those are the kind of things that are going on. Now the CPU is always faster, a little bit faster than the GPU. What is the need for CPU to be faster than GPU? Because if you get any kind of interrupt from the GPU, then you cannot process the interrupt because the CPU has to run a little bit faster so that it is able to process that particular request of what the interrupt is and at least do a few instructions. Okay, so that is why they gave a slow clock to the the kind of IO devices and other things, rather than fast devices and the fast on CPU. So the central processing unit is a bit higher processing area, and GPU is the general purpose here. General purpose proper processors are called GPUs, okay, or IO processors are called GPUs. So basic system architecture for Cisco is the same thing, okay. So it has got a set of ports, okay, say for a switch or a router or a hub or a concentrator. This is all, it is all a kind of operating system. So there is basically an iOS operating system which is converted, mostly something to do with specialization of some kind of BSD systems where you are going to use a different form of things. Okay, so router is different from basic Unix operating system, but though it has some features of routing within a gateway. So some of the things are called gateway because those kind of things allow for such kind of routing. Some Unix operating systems and other operating systems they use for some kind of, they allow for some of the configuration, but they don't allow extensive things. Okay, so we cannot do too much of configurations on a particular port, or you cannot have 10 or 15 ports servicing, those kind of things are there. The gateway is a kind of thing which it connects between some kind of two routers to do the address mapping and things like that. So basically routers are going to do what? It is going to get the address of particular ports. Okay, and one side it receives, when it receives a packet, it is going to find the address for the particular destination packet, and it is going to make a connection from that thing, and it is going to make a connect to another port where the destination address is, and it is going to search for the destination port on which it has to send. That's all. So it is going to get an input with the source address and a destination. So the source address is not used while doing a mapping. Okay, so once it gets a source address from a particular device, then it processes or looks at the destination address, creates its own address table. That's called address table. Okay, so destination address table, and then forwards it onto that particular kind of interface or the port on which it is going to go and link to the other side of the network where it is going to. So there are different kinds of things like local area network, wide area network, then those kind of things are there. So so they work on different levels also. Okay, so some of them are switches, which means that they directly work on the hardware, and from one side if something comes in, it is thrown into the other side just based on the MAC address. It's called a media access control level. Okay, that is the lowest level of hardware. So lowest level of hardware addresses is just forwarded, and once they are forwarded onto a particular port, it is going to be called a switch or a concentrator or something like that. Concentrator is mostly used for if I have 10 computers connecting onto a particular concentrator, then those 10 computers which reside there, they are going to be interconnected through only a switch or a, the kind of hub or something like that. Okay, so everything can see the every other computer on the network. Okay, that is mostly the feature of a hub. Okay, so they use some kind different kinds of protocols so that you cannot duplicate some of the packets if we cannot connect them in a some kind of circular fashion where the things go on rotating on a particular. So if you connect two hubs, okay, so one is connected to the other with two ports. So what happens when it creates redundancy like that? What happens is basically one thing sees that the thing is on the other side, or the other side thinks that it is on this side, and the packet gets on looping on one particular from A to B, B to C, C to D, C to D, and back to A. Okay, so if you have A, B on one of the things and C, D on the other side, so the thing can loop A. You have two ports A, B on one router and C, D on another router. Then what happens? So from A to C, it is going to come in, and from C to D, it is going to go. It is going to be forwarded to C to D, and then it back again goes to B, and it forms some kind of circular loop of the packet and those kind of things. They are avoided by what is called spanning tree. So everything has got a different protocol levels to control all these things. Okay, so that you don't have any mismatch on the things on kind of popular routing and other things, routing switches, hubs, and other things can be there. So GPU, as far things are concerned, is basically used for what? These kind of routing things, okay, routing things or switching things. So there's a special memory, and part of the memory that is used, as I have told you, so it's 8-core processor for your cell phone. Okay, so it has got two main memories, so that is going to be used for some kind of processing alone for the shell of the networking commands and other things. Okay, so the other four processors are going to be other 336 processors. So totally, if you have an octa core, so the six processors will be used for it is for the six ports that are going to use on a particular router or something like that. So the special memory is used for only kind of routing table or switching table or MAC address table and things like that. So MAC address table is just a kind of resolution. If you have 10 computers, you'll have 10 MAC addresses coming in, and you have 10 ports that are going out. Then you have the different kinds of destination address for those. So source address of the 10 computers plus the destination address of the computers of the destination of each of the computers are linked to each other as a kind of routing path that is called a switch routing switch switch table, or you can call it as a MAC table and things like that. Okay, media access. That is how they find out. So they search for the MAC table and then immediately just send it on the other side. That is at the lowest level of the MAC. Then if you have going into a bit higher level, then it is going to be what is called a gateway. That is going to do a little bit, a little bit complicated. So it is going to use some kind of routing table and other things. Okay, so switch is the fastest kind of thing, where it is the routing table is a little bit faster, and if you want to connect two hubs and to a switch, then the things are going to be speeded up a little bit faster. So you have to know what is a switch, what is a hub, what is a router, okay, of Cisco systems and things like that. So different kinds of configurations for each one of those. The command list is a little bit different for each one of them. Okay, the command list, what do you mean by a command? Just like Unix command, you have a list. Okay, list means what it is going to list the directories of the particular system. So similarly, you are going to just show route. You are going to say show route. Okay, so it is going to show you the routing table. Okay, or it is going to show you the MAC table. So show MAC means it is going to show you the MAC table. Okay, the table, how many source addresses are there, how many destination addresses, how they are linked, and those kind of things. So if you have a routing table, it is going to be a little bit complicated. Routing table usually has the number of hops associated with each one of this routing configuration. So it has got Say we have four routers connected as a linear kind of thing, then what happens? First it goes to the first router, then it is going to go to the second router, then it's going to go to the third router, and then it's going to the fourth router, and then finally it is going to find the computer on the other system, other side of the router, and then it is going to resolve all the addresses, and it is going to form a path, and all these trace, complete trace, is going to be stored uh, in the destination routing table. Okay, similarly the source table also has the same kind of thing, where it is going to store all the information. When a packet comes from the other side, then it is going to show the complete kind of routing table and other things. Okay, so some of them they use what is called a mask or something like that, so that you don't go creating a huge routing table for that. So if it sees some of the things, this is the packet that is going to go on this port, this router, then it is not just going to just converge to that particular area, and it is just going to go and give the address to that. It is like finding a address of a particular person in a huge complex or something like that. So you just resolve the thing, and finally find the go to the destination on particular. So based on the levels of resolution of particular address of a particular person from a post office or something like that, then that is called. Once you just corner in some other things, the whole sequence of things are like door number, then you have the street number, then you have the. So this is just the addressing. Similarly to that, so the person address is also the final thing where you're going to give it to that particular person or something like that. So something like that only usually. Its routing is something similar to that, but it is going to store the complete address, okay, in each one of those hops. So in case of postal and other things, it's going to be the final routing thing that is going to be there. So if it is USA, say you're sending some mail to USA, then the first thing it is the first looking at the last part is India or USA. Immediately you're going to throw it down to USA. So you're going to have a router or a mail van which is going to go, or a flight which is going to go to USA, and you're going to just throw the letters there, and you're just done with it. And after that you don't look into it, and it will find the final destination of the particular US address. Somewhat similar to that, it is going to use some of the routing tables and routing table addresses, and you're going to corner in some of the things what are called zones, what are called domain, then you have domain clusters, then you have what is called filtering, then you have what is called forwarding, then you have what is called network masking. So IP address is the one which is going to be used for different, almost like millions and thousands of ports are there on the network. So millions, even billions are there. So the main routing kind of information is going to be done by what is called IP address, and you have different kinds of IP address also. Okay, version 6 IP address is the maximum kind of thing which you can use for routing, and maximum number of hops you can take, and finally find the destination for the particular router or for particular system in the network. So we have, see, if we are running a cell phone, there might be millions of cell phone on the routing table. Okay, and each one of those routing table is resolved and cornering onto particular kind of cell phone that you are going to use. Okay, usually the cell phone works in a different kind of principle, using kind of like not routing table. It's going to have telephone trunk, your number system kind of use. Even some of them are embedded, your telephone number is embedded onto the IP address or resolve kind of things, and it might be sent to your particular kind of system and other things. So today we are going to look into the iOS kind of architecture or router architecture, how we can do. So usually you can assign all the GPUs to the different ports on the particular router. So your shared memory, everything is going to be that particular processor memory is going to be used for I/O transfer. I/O transfer is input-output kind of thing, and it's going to be used for that particular port, which is, say, whether it is an Ethernet port or some kind of long distance port, or you can do a Wi-Fi kind of port or other things. So it is going to use that particular kind of port. To do satellite port also is there, or fiber link ports and other things. So those kind of things will be used for how much of data you can transfer onto it to a destination router. Routers, basically why they are used is for long distance communication, high bandwidth. That is why they need routers. Okay, otherwise, if we don't need high bandwidth, high data transfer and other things to different places, or long distance and those kind of things, and too many number of people are using, you don't need any routers. If there are five people only going to use the computer in some place, then why do you need a router and other things? You don't need any kind of router. But if you want to get information from different places, you want to do kind of finding the address, and if you want to send a mail to some kind of distant place in USA or Germany or France or something like that, then you need all this routing table and other things. If you want to communicate something with someone in China, Japan, Korea, and those kind of things, you need all these routing tables and other things to control all the things. Again, the speed also depends. You have 3G, 4G, 5G and things like that. So but if you have a 5G network and all, if it is a long distance 5G networks, then routers are mostly used for finding the fastest path, and it keeps a count also, a hop count and other things. There might be different parts in the network depending on what kind of, this is a kind of net mesh kind of net or something like that, star kind of topology and other things. So different routers are there. The intermediate router for, if you want to send a packet really fast, the intermediate router is going to give the routing table resolution and other things. From one router there might be more than three or four or different paths to another thing. Okay, and from that four it can be another four which has different kind of paths. So the number of things that is going to be routing table is going to be used is quite huge. So in order to reduce all the things, that is why you have kind of masking. So you have to give a mask for that particular system and kind of thing. So the address restaurant, and you create a routing table which, so it is going to go through 5 hops. Some other path might be 10 hops. So if your router is down, it might be 20 hops. Okay, taking a different path. So 20 paths, that routing things have to be stored in your routing table, so that you can send the packet to the destination thing. Every time you are sending a packet, it is going to, so there will be millions of packets coming onto that particular kind of connection. Say you have Google or something like that, so there might be 10 million people working from different areas and different people, different kind of thing, and it is going to go into the data center for the Google's kind of thing. And you know everybody is looking on different things and other things. So they'll have different routing tables and all these things. This is all done by what is called Cisco systems. And so mostly for doing all this processing they use all the GPUs, because the routing table is extremely huge. Okay, so 6 GB means 1 GB or 2 GB minimum for a port is used. And even some of the things they use a special kind of shared memory architecture where you can have extremely huge routing tables and other things. Some of the powerful kind of things, routers and other things will be why routers are not used and some other kind of system is used or something like that. Systems are mostly for local kind of thing, doing fast processing and other things. So if you want to go and to Google and do all the things, then what happens from here? The routing table fixes the path for you and creates a channel, a specific kind of channel for you. So anything is generated, go to under router, and that particular different types of routers, it makes the hop and finally gets to the destination. So there is a channel that is created for you already. And if something misses right in the middle, then that particular packet is not going to go. So the TCP layer, that layer above, takes care of the next packet that it is going to generate. Once that doesn't receive any acknowledgement from the other side, then it is going to say that the routing table is not okay. So it is going to adjust to the next hop kind of thing and then use the next routing available that is hot and it is running and it is working, those kind of things. The links are sometimes created on the routing table also. So the routing table update is one which happens as the network goes down on one side, network comes up on the other side, those kind of things are there. The link is, some fast links are coming up, some slow links are going down. Those kind of all those tribulations is taken care of by the routers. That is why they use routers on everywhere to connect different devices. And but the processor is running extremely fast and other things. To say a server is running extremely fast and it wants to send so much of packet information and other things to different, almost like 3 or 4 different systems at the same time and things like that, then it is going to use the routers and other things. Okay, so so usually the processor architectures is the main memory might be used, or the first two processors might be used for like G55, 556 and things like that. Those can be used for routing table address resolution and other things. So you need huge memory of amount of memory. Number two, you need to extremely transmit the thing to the particular packet. So it is going to allocate first routing table, then it is going to allocate space for the number of packets that it's going to route. So it's basically it is going to create all these channels for you. So for don't think that it is not going to provide some kind of service on that. So it is going when you are sending a packet, you cannot just go to the final destination straight away. Okay, you cannot go. So what you have to do, you have to allocate a channel buffer memory, which goes to the first router, the second router, the third router, the final the destination router, and then goes to the final computer where it is going. So it has to allocate how much memory, it has to negotiate all these things in the intermediary, and routing table is the first thing that is going to be, and shared memory are the different kinds of memory for that particular port. So depending on how much of memory port you have for a particular port, a number of ports, or or how many number of kind of how much of memory is needed and things like that. So packet switching is going to be a full packet has to be received on one side, and then it has to be forwarded to the next router, finally to the destination, attaching the different kind of path it has taken, and finally to the, and it is going to strip all the things once it goes to the final solution, and the final packet is going to be delivered to that particular kind of things. It's some kind of tagging that goes on, intermediate, and finally it goes to, and channel allocation also you can do, so that the packet is not lost in between. Of course, with the routers, some of the routers, if they go down, then the packet loss is there, but still, the end takes care of the thing, and if something is missing, then it's going to resend the whole thing back. And when it's going to resend the whole thing back, it still looks at the routing table and finds the new kind of routing address where it can send. So the next appropriate routing address is the one which is going to be taken and then given it to the from the server. It is going to go and find the final server. So this routing table is one thing. Another one is memory allocation for each one of those channels is another thing. Then what are the third thing that is going to be used for? So there might be other system tables which can be used for that particular router or a hub or a switch. So router is basically using to use about 4 or 5 processors called the CPU, GPU, LPU, MPU, TPU, and things like that. So TPUs for tunnel processing unit, or tunnel processors, and so each one has got different PU kind of things. Okay, so don't think you have only GPU or CPU or something like that. Okay, the GPU itself has got different naming conventions and other things depending on what kind of router you're, whether you're going to just use a terminal type kind of thing, whether you're going to use a serial port kind of thing, whether you're going to use a wide area network kind of features, or you're going to do a different routing which is going to use different types of things and other things. So those kind of things are all those processor, those which are going to be used called CPU, GPU, LPU, TPU, MPU, and things like that. So they got different naming conventions for each one of them depending on what kind of IO processing. Last time we saw only screen processing, then you have touch screen processing. Those are all done by GPU for each one of those IO, like camera and things like that. So similar to that, it is going to use all the. So camera is going to produce about 10 million pixels per second. Okay, so about 10 million, probably 10 million. Oh no, half of that. Say maybe something less than that. It is going to produce about one meg packets, or 1 meg pixels pixels, or 1 meg bytes per second. Okay, so even if you take 1 pixel, it is going to be 1 byte or something like that. Then it is going to be one one 1 megabyte kind of processing speed, and then what 1 megabyte processing speed is going to be transferred to the thing to the other side, so they have the complete screen on the other side. Then you have to create a channel for the 1 megabit tunnel through
where you can go into different routing things, and you have to allocate so much of 1 megabit. So you cannot see a video from here directly on the other side, so unless you get a good camera, and the camera has 1 meg allocated on the one side of the thing, and 1 meg allocated on each one of those routers to do the forwarding of the routing. So it is immediately going to transfer all the things to the other side. So it is a kind of tunnel through which is created, and the bandwidth also allocation also is there. So depending on what kind of service you want to do, so for end-to-end camera services, then it is going to use high amount of bandwidth. Some kind of end-to-end touch screen is going to also use some kind of high bandwidth. Some kind of routing also is going to use high bandwidth and things like that. So depends on the complexity is little more. If you're going to use servers where you're going to do huge data transfer, like database for banking, so because those things banking and all they use extremely heavily, and even for air flight reservation system, train reservation, they are going to use so much of. You have almost like a million kiosks on the wall, and each one of those kiosks is going to do different kinds of surveillance service. Then you have banking transfer service, hard cash services, and commercial services and kiosk services. So many things that they're going to be used, and for that you have to do different kinds of allocation methods, the processing power. That is why you have multiprocessor architecture, which is going to be used heavily. And again, the network is also going to expand, because that also kind of like you have to find different paths to control the traffic, because number of people that are going to use the network is going to be extremely. And if we have some of the cars and other things coming in, automated cars and automated service systems and things, is the amount of bandwidth and amount of memory allocation on each one, amount of processing on each one of the servers, amount of processing that is needed in each one of those routers. Routers are basically going to kind of reduce the end to end kind of work, where it is going to allocate some kind of specific bandwidth to it, so that you can just tunnel through, kind of thing. So tunneling is another thing which is going to be used in. So configuration of iOS sister router is like, you give the iOS command like Cisco config. Okay, router, there will be the first prompt that is coming in, and you can give config router port 1, channel bandwidth, say about 500 meg or something like that. So anything around 500 meg is coming, it is going to use the first port. Anything above that, it is going to go to the next port. Another one is out. So those things are cut. So sometimes it can break down the complete thing in the path, and multiple the assembly is done on the other side. So if you have a channel bandwidth that's about 1000 bytes, and if you're going to send a packet of 2000, then once it receives the 2000, it is going to be broken down into 1000 and 1000, depending on channel allocation. It is going to send the first thing. So you need for 2000, you have to allocate the memory for 2000 and use only the 1000 bandwidth channel to the send to the other side, and the next packet is going to be attached with the routing table to the next hop, with the extra kind of features that is going to be in there. And then it has to go break the packet and send the next packet onto the same channel, which is just less than the amount of data that you're sending through. So for video conferencing and other things, so some of the packets might be broken right in the might be kind of in the channel, depending on channel location, it might be. That is why sometimes you have a clear connection on the end to end video service. Sometimes you may not have a clear end to end video service. Some other things are broken or something like that. Sometimes a delayed kind of things. It might be a little bit of delay, but still it works, because channel allocation finds the best path route for kind of, if you're going to say minimum of 100 meg going on the other side, then it is going to find the tunnel through kind of services which is going to be used, so that you can have the video conferencing. So once you make a video conference call, immediately it knows that it is going to have channel allocation has to be increased. So you might be some kind of voice channel that you are talking to the other side, then some suddenly want to switch to a video call, then immediately it allocates a different kind of special channel, or it can increase the bandwidth right at the middle of the things, and then the routing tables can be increased. And these things are all taken care of the routers, the servers that you are using, and other things. So banking services and all, you're going to use heavily, because the amount of transactions that is run per day on a kiosk is like within a particular region is going to be about minimum about 50,000 transactions, or even 1 lakh transaction might be done, and some of the organizations have even 20,000 30,000 transactions which is going to be there and is going to be routed to the other side, and some of them use for monitoring also. If you're sending goods from one side, they use video monitoring and other things for to reach the other side. Some of them routing monitoring also they do. So those kind of services require huge amount of bandwidth and huge amount of memory and huge amount of server configurations and other things. So networking plus the networking is one of the thing. Another one is server access. Another one is games. Another one is database, and another one is other kind of services like weather reporting services, and all those things are going to use huge amount of IO. And some of the things are even surveillance. Some of the things are temperature sensors, from end to end temperature sensors, end to end, from one side of the globe to the other side of the globe, temperature sensors and transfer of kind of information and other things. So even for sort of the flight control management, remote flight control management, remote car vehicle management, they also require some kind of bandwidth, and it has to go through the different. The complexity is a little bit huge, but still it has to make end to end work. So the thing which is going to run on this is a TCP route, TCP kind of layering, which is going to take care of all that. But still, at the lower level, all this routing table happens. Though they are all done by Cisco, iOS, and other kind of routers, routing features that is going to be available. So if you have just a camera and you have your local kind of system which you want to connect to a particular camera, that particular bandwidth has to be allocated. And if you want to go over the network, some other different kinds of bandwidth is going to be used. And if you connect to a remote IP and remote camera, those services are all different kinds of categories are coming in. So CPU is the critical thing. First level is CPU, then you have GPU, then you have LPUs. Basically, it's a kind of for kind of channel kind of services which is going to be. So if on a single interface you can have different kinds of channels that is coming in, like video services. Like if you're sending a you know live TV and other things, they are going to use different kinds of channels. They demand the live channels are running, and so it is going to use different kind of services and other things. Okay, so memory requirements are going to be a little bit different and things like that. So the whole thing is about how much of processing power, how we can define all the different kinds of operating system for each one of the systems. Like for a camera, the system is going to be different. If you have 50,000 cameras connected in series, then you have to have a different kinds of services. It might be a cam router or something like that. So it might be cam routing, or it not be even cam routing, cam multiplexing, or cam other kinds of things can be there. Okay, so channel allocation. So just a cam can have a different kind of system architecture. So routers are used for routing, network for another things. And so if you go into neural networks and other things, it is one level bit higher. Okay, so as for things are concerned, these are the basic things of why you want to use higher processor, and what kind of system architectures you can do, and what are the future system architectures that might be used. Okay, those kind of. So IO is the basic kind of architecture. IO plus memory plus processor. These are the basic things that you consider into systems and other things. Okay, that is all for today about system architecture. So basic BSD systems, Unix operating systems, and all are used for high-end data processing and other things. So BSD in Unix are the highest number of things used presently. Okay, there might be other kinds of real-time operating systems which are not used much, but though they are used in defense, critical things and other things and all. Okay, there are other versions of Unix, versions of iOS, versions of networking stuff, network versions of surveillance things and other things. Okay, so that might be just an introduction on what are the different types of processor, what are the different kinds of operating systems you can write, and iOS is one of the particular Cisco operating system just for routing, switching hubs and concentrators kind of thing. So different OS will be generated in the future. iOS is internet working, so it may be iOS. It might be intelligent operating system. So that might be a different kind of thing where you can come into the future and do all those other things. Or neurally NIOS is might be now, kind of like a network intelligent operating system or something like that, which might be using a different kinds of intelligence might be used. Routing table alone is not the use. It can maybe even the routing table can have some kind of intelligence embedded, so that you can do a different kinds of configurations. You can have neural networks and things like they all kind of machine language learning and architecture for robots and other things and are a little bit different. Okay, they also come under the same category. You can define configurations for those, create networks for those, and use optimization methods and other things. Okay, so this is general overview of how the things might look into the future. Okay, that is all for today about CPU, GPU, MPU, and shared memory and RAM locations, and multiprocessing, multiprocessor architecture support, about 8 CPUs, 8 octa-core CPUs, and hexa-core CPUs, and deca-core CPUs also are available. Some other things. Okay, so that is all for today about multiprocessing, BSD, and some of the future system architectures and OS architectures. That's all for today.